All right, let's try this video again. I am trying it with a different orientation, so hopefully it'll fill up your screen a little better. And I am assuming the mic is on this time. It wasn't on last time, and I apologize for the accidental silent video. Anyways, today we are doing trigonometric ratios. So the first thing we need to know about this is it only works for right triangles, okay? So this is for right triangles only. And when we're in a right triangle, if we want to talk about the opposite and adjacent side, we are talking about them in reference to an angle. So the opposite side to a non-right angle in a right triangle is the leg of the triangle that does not touch that angle. And the adjacent side to a non-right angle in a right triangle is the leg that does touch the side, or does touch the angle, I'm sorry. And I refer to that angle as the angle of interest. So in my next set of examples, let's draw ourselves a triangle here. I forgot to preload my triangle. So our triangle is triangle ABC, where B is the right angle. The first example says, for the triangle, state the side opposite to angle A. So I'm going to highlight A in yellow. And the side opposite to it, remember, has to be one of the legs. So my options are CB or AB. And this side here is going to be opposite to angle A because it's the leg that doesn't touch it. So my answer here is segment BC. Don't forget your little segment above it. And then the side adjacent is the leg that touches angle A. So then this would be adjacent to angle A. Okay, so my answer for part 2 is AB. And if I look for angle C for part 3 and 4, the side opposite to C is going to be AB. So this is opposite to angle C. And the side adjacent is the leg that touches angle C. So that is going to be this side here is the adjacent side to angle C. Okay. So the side opposite of AC was AB. And the side adjacent to angle C was BC. All right, next set of definitions are our actual trig ratios. So we have these ratios, sine, cosine, and tangent. And we skipped the chapter temporarily on similar shapes, but if we have similar triangles, the ratio of the sides is always the same. And when I have right triangles, if I know one of the angles is 54 degrees, then any other right triangle with a 54-degree angle is going to be similar to any other triangle with a 54-degree angle, meaning the ratio of the sides is the same. So these three ratios are going to be the ratios of the possible sides of a right triangle. So when we get into some examples, it'll make a little bit more sense. So the first one is the sine ratio. So we say that the sine of an angle is the length of the side opposite that angle divided by the length of the hypotenuse. Okay, the cosine ratio of an angle is going to be the length of the adjacent side divided by the length of the hypotenuse. And then the tangent of an angle is going to be the length of opposite side divided by length of adjacent side. Okay, And a good way to remember this is SOHCAHTOA. And so we can say sine, we abbreviate SIN. So sine of an angle is going to be opposite over hypotenuse. Cosine is abbreviated COS of your angle is going to be adjacent over hypotenuse. And tangent, oh, I already abbreviated it. Tangent is TAN. So tangent of an angle is opposite over adjacent. And when I look at the SOHCAHTOA, the SO is S is OH, and then C is AH, and T is OA for sine, opposite over hypotenuse, cosine, adjacent over hypotenuse, and tangent is opposite over adjacent. Okay, so pause the video, try the examples, and then press play and see how you did. The first one, write the sine, cosine, and tangent ratios for angle J and angle K. So the first thing we need to do is we need to make sure that we have the length of all three sides because we need both, or we need all of the opposite, adjacent, and hypotenuse for all three trig ratios. So to find the hypotenuse, I'm going to say 3 squared plus 7 squared equals my hypotenuse squared, which I'll call C. And I get 9 plus 49 equals C squared. So then I get 58 equals C squared, or C equals the square root of 58. So there's my length of my hypotenuse. All right, so let's figure out angle J. So the sine of angle J equals the opposite to angle J. So if this is J, then this side is the opposite, and this side is the adjacent. Okay, and then my hypotenuse is always square root of 58. So opposite would be 7 over square root of 58. Now remember, for simplest radical form, I'm not allowed to have radicals in the denominator. So I'm going to multiply the top and the bottom by that square root of 58. And my answer for sine would be 7 root 58 divided by 58. And then cosine of angle J is going to be the adjacent side to angle J, which we said was 3. And then the hypotenuse again is on the denominator. Multiply top and bottom by that square root of 58. And I get that the cosine is 3 root 58 over 58. And then our last ratio for angle J is tangent of angle J is going to be opposite, so 7, over the adjacent, 3. And there's nothing we can do with that. Okay, next, we're going to look at angle K. And if we're using angle K as our angle of interest, now my sides are no longer, the legs are no longer the adjacent and opposite of what they were a second ago. So now the side with length 3 is my opposite side, and the side with length 7 is now the adjacent side. So the sine of angle K is going to be the length of the opposite side to angle K, which is 3 divided by square root of 58, which we already found was 3 root 58 divided by 58. And the cosine of angle K is going to be the adjacent side, which is 7 over root 58, because that's my hypotenuse still. So 7 root 58 over 58. And then the tangent of angle K is going to be 3 over 7. So the next question asks, what do you notice about the ratios in example B? Well, it looks like my sine and cosine of these angles flip, and then my tangents are reciprocals. Okay, and so that's going to be true. These are called co-functions, so sine and cosine, and they're equal when my angles are complementary. Okay, so the CO has a significance there. So we notice that the sine of an angle is equal to the cosine of its complement. Okay, and that's always going to be true. And the tangents of complements are reciprocals. The tangents of complementary angles are reciprocals. And reciprocal means you just flip the fraction. Okay, next example. This one you're going to need a calculator. So if you have a scientific calculator or a smartphone, go ahead and pull that out. And we're going to find the value of W to the nearest tenth. So for this one, we're given angle measures and asked to find the side measure. So go ahead and just pick an angle. So I'm going to pick angle 33. You could also pick angle 57. It doesn't matter. So if angle 33 is my angle of interest, then 2.5 is my opposite side, and W is my adjacent side. So I have to go through which trig ratio, sine, cosine, or tangent, uses opposite and adjacent. Well, my tangent ratio does. So I would say that the tangent of 33 degrees equals the opposite, 2.5, over W. And now I need to solve that. So I'm going to multiply both sides by W to get rid of that fraction. Okay, so I get W times the tangent of 33 degrees. And I know the tangent of 33 degrees does not look very pleasant, but it's just a number. You can plug it into your calculator and figure it out. And so the tangent of 33 degrees actually is approximately 0.649. And we rounded that, so I actually should use my approximate symbol here instead of my equal sign. And then I'm going to go ahead and divide by that 0.649. And I get that W is approximately 3.85. Okay, so one thing to make sure you're doing when you use your calculator is we're in degree mode. And so the calculators also have this mode called radians, which we're not going to use in this class. So make sure your calculator is in degree mode. And if you want me to help you with that, if you're getting the wrong answer instead of 0.649, email me and let me know and I can walk you through those steps. Okay, make sure your calculator in degree mode. All right, our next example. Oh, this one looks wordy. Here we go. This is exciting. The trigonometric ratios have been known for centuries by peoples in many cultures. The Polish astronomer Nicholas Copernicus developed a method for determining the size of orbits of planets closer to the sun than Earth. The key to his method was determining when the planets were in the position shown in the diagram. Well, I have to draw you the diagram because I didn't put it in here. And then measure the angle to find A. So if A is 22.3 degrees for Mercury, how far is Mercury from the sun in astronomical units? And one astronomical unit is defined as the average distance from Earth to the center of the sun, which is about 93 million miles. Okay, so let me draw you this little diagram here. So we have the sun. I'm going to add some space here so I have room for my diagram. So we have the sun going on here. So here's our nice, beautiful sun. And then around the sun, Mercury orbits. Okay, so here is Mercury. And then a little further is the Earth's orbit. So here is the Earth. And together it creates this right triangle here. And this distance here is 1 astronomical unit. And this angle here between the angle from the sun to Earth to Mercury, that's my angle A. All right. And we are looking for how far the sun is from Mercury. So if this is my angle of interest, A is my angle of interest, then X is going to be my opposite side, and the 1 astronomical unit, the distance from Earth to the sun, that's going to be my hypotenuse because it's across from the right angle. Okay, so which trig function uses opposite and hypotenuse? Oh, that's sine. So I'm going to say that the sine of A equals X over 1 astronomical unit. Then they tell us that A is 22.3 degrees, so I'm going to plug that in here. So the sine of 22.3 degrees is going to equal X divided by 1 astronomical unit. So then I get that the sine is 22.3 degrees is equal to x, and I can multiply that by 1 astronomical unit, but it asked me just for the answer in astronomical units. Okay, so I'm going to get that my answer here is that x equals, oh, sorry about that. I plug that into my calculator, and I get x is approximately 0.38 astronomical units. Or if I want to multiply it by that 93 million miles, I get it's about 35,340,000 miles. Okay? All right. So the next thing we're going to talk about is inverse sine, inverse cosine, and inverse tangent. So what these functions are is these functions, I'm just going to abbreviate here instead of writing a new one for each of them. These functions take my ratio as the input value and they give me the angle measure. Okay, so the inverse functions flip the values of the angle measure and the ratio. Okay, so for example, if I had sine of angle A equals opposite over hypotenuse, then the inverse sine, which we write as sin with this exponent of -1, is the opposite over hypotenuse ratio. And when I plug that into a calculator, out is going to come the measure of angle A. Okay, so let's do an example so you can kind of see how this is used. Okay, so our example says find the measure of angle L to the nearest degree. Okay, so angle L, so here's my angle of interest. So I'm going to write all my trig ratios in relation to that, or sorry, all my angle sides. I'm going to write all my sides in terms of relation to angle L. So 3.2 is my side opposite. 2.4 is my side adjacent, and 4.0 is the hypotenuse because it is across from the right angle. Okay, I can use any trig ratio I want. I'm going to pick, let me pick cosine because we haven't used cosine in a while. So the cosine of angle L is going to equal the adjacent over hypotenuse. So the adjacent side is 2.4 and the hypotenuse is 4.0. Okay, so adjacent over hypotenuse is what that was. So when I want to use the sine ratio to figure out what angle L is, what I'm going to do is I'm going to flip these two, and now I have to write it as cosine inverse of 2.4 over 4.0 is going to equal the measure of angle L. To get this on your calculator, to find the inverse functions on your calculator, you most likely have to press a button that says second, and then press the sine or cosine button, or the cosine button in this case. So find that second button and see how that works out. And you should get, when you plug in cosine inverse of 2.4 divided by 4, you should get 53.13 degrees is the measure of angle L. And so it says to the nearest degree. So my answer here would be 53 degrees. Okay, and you could have used tangent or sine as well. Your fraction would have been different. Okay, and that's all I have for you today. Sorry the first version of this video didn't have sound, but luckily this one does. So let me know if you have any questions. Thanks.